Hi there, everyone. Thank you for tuning into Virginia Clean Cities Technology Happy Hour. This happy hour was recorded in March 2025 with one of our partners, DC America, to tell us all about their goals in the clean energy design space. If you'd like to learn more about Virginia Clean Cities, please visit the links below. And if not, we hope you enjoy listening.
Like you said, I'm Nathan Bowen, DC America, president, co-founder, DC America, West Virginia-based um, company, manufacturer. So basically, we manufacture. Get my screen going here. There we go. We design, manufacture, commission, and ship above ground, minimal dig, turnkey, single point connection charging depots. So we're also working in the battery energy storage space, pre-wired, manufactured power distribution systems. So some of our products will probably eventually start showing up, data centers, things like that. So anything that can be modularized, pre-manufactured, pre-wired, and commissioned before it leaves the facility. We're looking in those markets, but mostly at this point working in the EV charging space. And probably the majority of our work is more behind the fence fleets, drayage applications, bus, school bus applications, heavy duty truck, last mile, middle mile folks. We do a little bit of public facing as well, but the majority of our work has been behind the fence. So as you can see here in the bottom right, that's actually one of our stations being shipped to a facility in the Northeast, port facility, I believe is in New Jersey in that case. Um, just to give you, I think, a video, a time lapse video to be more specific shoot, is worth 1,000 words. So this is one of our deployments here in West Virginia. Is actually at the Army National Guard, just to kind of show you, give you a feel for what we do before I go any further. But everything's pre-wired on our skid. So basically, it's a steel platform. You seeing that getting set there. We can integrate in transformers, switchgear, metering, everything, and all pre-wired before it leaves our facility. So what would take weeks in the field, in this case, we were able to basically deploy this station, um, in the morning, basically. So less than a couple hours, this unit setting, and the only connection to the utility was a few conduits going to the utility transformer itself. Unique, um, aspect of this job, but it was a combination of DC fast charging and level two. So, and I'm kind of talk towards this as this presentation goes along, but kind of speaks towards the resiliency of this and adaptability. But basically, this platform, today it has the majority, level two chargers on it with a single DC fast charger. But in the future, the capacity is basically built into our system of being able to, mount and wire DC fast chargers and replace these level two chargers as demand increases. So really what I'm trying to talk about here today is, enhancing resiliency and just some of the things. It's not only on my products, but just stick build operations, or conventional construction. This can be applied to all aspects of charging infrastructure. Some of the main points I'm going to try to hit on here is just standardization, interoperability, redundant power supplies, utilizing multiple power sources, communications, redundancy, some of the things we're doing with weatherproofing, as you can see a picture there of some flooded superchargers, some ideas, regarding scalability and future proofing. And then, one of our latest jobs, which was more of a public facing project in West Virginia here, the Parkways Authority. We've put in a few charging stations here on the turnpike with a couple more coming. But just some things we've done on these projects that you really can't see from the outside, but deep down inside, there's some, strategies that we've used to help with uptime, future proofing and scalability and resiliency ultimately. Standardization and interoperability, especially during the design and construction phase. I'll see people installing infrastructure, especially with typical dig conduit, you know, concrete foundations. And you'll see them maybe put in maybe an extra capacity conduit or something like that. But really, when you look at it, there's a little more to it if you want to build for the future. So ensuring compatibility with different hardware brands and systems. So one of the things we do, you can see one of our systems here with the, this isn't complete obviously, but some of the wiring installed. But our top plates are all standardized. So basically, we are putting steel top plates that cover this structural raceway to mount our chargers, electrical gear, all these kind of things. So we standardized on 3 foot by 3 foot top plates. So that same 3 foot top plate, we could mount any brand of charger out there, within reason. Lincoln, AVV, you name the brand, Heliox, Altel, Light-On, all these different brands can be mounted to these top plates. So let's just say if brand A went out of business, which happens quite frequently these days, went out of business here in the next year, you could no longer support it. This standardization enables you to easily, I'll mention this later in the presentation, but rip and replace. So you could basically replace this top plate, put another charger on it, and without doing any more digging, you could basically be up and operational with minimal disturbance to the ground. Redundant power supplies. When you typically look at gear, typically it's a single input from the utility itself, just feeding, the rectifiers are all in one chargers. Some of the things we look at with future-proofing switchgear, and also with the structural raceway itself, is accommodations for alternative power sources, whether that be battery energy storage, mobile systems, generators, microgrids, and then having the option to island as well. So what that can mean in a lot of cases is potentially multiple main breakers, depending on how many supplies that you're going to have coming into this particular unit. Microgrid controls, different things that can be built into this. One of the things you need to think about too, if battery energy storage or microgrids are, kind of on your roadmap, is looking at the bus sizing in the gear itself to make sure that you can handle the ampacity, looking at the mains to make sure that, you have bi-directional overcurrent protection, things like that. One of the things I would also consider in an installation, to make it a lot easier to tie into redundant power supplies, is quick connection terminals or cam locks. There's different brands out there. You'll see Hubble has a twist lock. Most of your major commercial rental places, they'll basically use on larger wattage generators, battery energy storage, those kind of apparatus, they'll use cam locks. So if you have one of these cam lock connection tap boxes, you can easily, with basically heavy duty extension cords, just plug these in and have your system up and operational off the utility, within an hour or so, typically. So building, the power supplies with this really helps for, those kind of issues where you're without power. Some of the areas in West Virginia, rural areas or hurricane prone areas, this can definitely make a huge difference in how quickly you can get your equipment up and operational. Communications. I've seen this pop up, rear its ugly head several times throughout the several years I've been in this industry, but cellular communications, a lot of the charger hardware manufacturers, or even CPOs, they're using cellular modems, things like that. I prefer hardwired connections for this, but in some cases that's not feasible. But having options, failover routers, which basically means you can have a hardwired connection, but have a backup with a cellular 5G or whatever 4G communication. It would basically seamlessly drop to whatever's available. These are great strategies for redundancy. Some cases, maybe twin SIM Modems can kind of help for this as well. If you have a specific provider that drops out, you can automatically go over to the other SIM card, which helps. In some of the fleet applications, local charge management control. I'm kind of giving a plug here. I guess the Mobility House, they have basically a localized charge management controller, which it eliminates the need to basically have this connection to the internet for a typical cloud-based charge management software. So having local control basically means they can island out there. They still use cloud, they still use the internet, but they can go for long periods of time and basically run energy management strategies, whatever charge management strategies they need to from a local controller. Weatherproofing, disaster readiness. I see this on the some of the ports, typically in flood-prone areas. I've had multiple projects where we've designed and basically ended up putting some of our charging infrastructure up and out of the floodplain. So that's basically what you see here in this design. This one hasn't been built yet, but it's in the design phases. But basically all the rectifiers, switchgear, transformers, all the high-end, very expensive equipment that goes into, in this particular application, a drayage truck application, we're basically raising it up and out of the floodplain. And in the lower areas here, we have float switches to basically automatically shut off the power, once it gets to a certain level. So automatically shutting the power off. In this case, the client was not as concerned about the dispensers themselves, but they definitely want to protect their rectifiers, switchgear, all those kind of things. So able to get this basically up and out of the floodplain for a reasonable amount of money and protect this for future use. Redeployable assets, I see this especially in hurricane states. I'm starting to see this in California. Some interest in potentially redeployable assets to be able to pick up and move it out of disaster's way, or in some cases, folks want to have the ability to pick up and move. Let's just say it was a turnpike in Florida, be able to pick up their infrastructure and strategically move it to an evacuation route to give EV drivers, a little more capacity getting out of an area that particularly would tax, local infrastructure beyond what it can handle. So being able to move some of this, redeploy it, and put it in some of these locations, kind of helps with the safety aspect of getting these folks out of harm's way. Scalability and future proofing. I kind of mentioned this a little bit earlier, but we try to in our designs, and I recommend this across the board, but design with expansion in mind, especially its transformer and switchboard. Get as much power as you can from the utilities. Build your switchboard accordingly. Basically have the ability to expand in the future, have the capacity there. In some cases too, in this is the Parkway for West Virginia. We actually added lighting and security cameras, but we built that into the switchboard, for this system. So we theoretically could have added these later to our system, which we, in this case, I would say, plan for that expansion, plan for those circuits. In these cases, these are single phase lights, so we had to add a transformer on top of the 480 volts that feeds the station. So having that ability, the room for those breakers and overcurrent protection devices saves you a lot of money in the future. Plus gives you some resiliency to be able to add on. Integrating with emerging technologies, things are changing fairly quickly. I'm starting to see more and more DC to DC systems to kind of take advantage of battery energy storage, coupling with EV charging. you know, you see some folks wanting to get away from all-in-ones to get to distributed DC systems for whatever reason, whether it be, they want some dynamic charging capabilities for a fleet application. Um, you know, with our system, and you can do this as well as stick built, but we basically have the open platform that this cabling system can be basically used to add cabling later, completely take out the cabling, put in another cable later on, add communication cabling, add cabling for lighting, security, you know, really thinking about your conduits or your structural raceway systems up front can save you a lot of time and money and effort later on. I mentioned this earlier too, but rip and replace, installation methods that allow easy replacement of antiquated. I'm seeing this already out of business hardware manufacturers. There's some hardware manufacturers that are no longer being supported. So, we have customers that are interested in taking those out, supporting their customer base, and basically switching out the chargers with something else. Pretty big market for that. Parkways, the project I mentioned earlier, just a quick case study on it and kind of what we did to, try to improve the resiliency and help with uptime, some of our strategies. But the Parkways approved a contract a couple years ago. I think it was in 2023 for not $120, but actually $120 million for the demolition and renovation of the Beckley and Bluestone travel plazas. So both these projects included EV charging infrastructure. The services we provided, we were selected to provide the charging hardware installation, operations, and maintenance, as well as charge management services. So Parkway owns the equipment. We're basically operating it for them, running the charge management software, taking care of all the O&M. Along with that, there's contractual uptime requirements, as well as the requirement for local qualified technical personnel on call for 24/7. And pretty aggressive response time. So they also had a need for rapid deployment. We basically got a notice to proceed on this somewhere around the November timeframe. Between the two stations that we have operational now, it's 1.8 megawatts. So in less than 2 months, we went from notice to proceed to a fully operational site. Power there, charging vehicles, the full operation. So pretty unprecedented timing for this. Really kind of helped with their opening up a route to the south and north through West Virginia that typically in the past was completely bypassed. Most drivers, EV drivers coming through this area would have to drive completely around the state. So this really opens up a lot for the EV drivers, throughout the state and throughout the south and the north on the East Coast. Some details of the project: the Beckley Travel Plaza included 8 150 kilowatt DC fast chargers with both NACS and CCS ports. It's either or. I shouldn't say either or. It's one or the other. So we have a total of 8 ports, and they could be either NACS or CCS. The Bluestone Travel Plaza between Beckley and Princeton has 4 150 kilowatt. Pretty much the same setup there, just a little bit less capacity. In the near future, milepost 69, which is between Beckley and Charleston, will get 450 kilowatt, just like the Bluestone Travel Plaza. Some of the measures that we did to help us with our uptime, resiliency, we basically built our switchgear, and in this picture, you can kind of see it's still under construction. But in this case, this is one half of, there's actually 2 1,000 amp switchgears on this. But the ability to use quick connections like these camlock connections to basically power up a mobile charger. One of the things, and I didn't really mention this earlier, but if you remember the picture that showed the raised platform chargers, and then the charging equipment for a port application. If you notice in that, there was 2 different hardware manufacturer brands. And I'm not saying necessarily you do this in a public facing application, but in a fleet behind the fence application, Yeah, I'm a pretty big fan of using multiple vendors at times. I've seen, complete outages with one vendor that can just completely decimate, a fleet's operation for that day. And a lot of these are critical. They have to operate. They have food they got to move, or kids they got to move, or whatever. So, you know, potentially having another brand of charger available, is a good strategy to employ. That's why in this case, we did use a different brand charger for our mobile application. So basically, what we can do if we do have a charger in order to meet uptime requirements, we will deploy this with one of our technicians, set it on site, and use the quick connections to basically get this powered up in a matter of probably less than 30 minutes. But give our clientele a charger that they can use. Hopefully these don't go down, but I've seen enough charging equipment out there to know that it happens all the time. So to think that you know this stuff is, let me just say this, 97% uptime without some kind of physical plan like this is silly in my opinion. I mean, you really need to have some kind of a plan that has physical assets that can be deployed and plugged in, uh, to basically give the technicians time to get these other units fixed. Sometimes you may be looking at days to get parts. We stock every part that are in these units here, so typically we can get these up and operational very quickly, but there could be an instance where something happens where we need this, so we have it available. We did do some options on the communications too, where these are public facing, so you're not only dealing with charge management but also point of sale. So all the communications that go along with that, some redundancy there with some failover communications options, help with keeping the uptime on those as well. Just a quick time lapse of one of the deployments there. This is the Bluestone Travel Plaza. Um, you can hardly see it, but you can see the conduits are already stubbed up in the concrete pad. Probably see it there in the light just a little bit better. But basically, the unit sits over top of it. This is our electrical switchboard, taking the power from the utility. So everything from that point on was pre-wired. So we would make our final terminations into that, power it up. The system's up and operational. Some of the strategies that helped us do it this quick in 2 months. Typically these infrastructure projects with permitting, these kind of things can take sometimes years. Pre-engineered standard designs allow for rapid manufacturing. We do have an in-house UL508A panel shop, so we're able to build our own switchgear. So the typical switchgear lead time, it's a little better now, but even today, I mean, you could be looking at, for over 1,000 amp, 12, 1600, 2000 amp switchgear, anywhere between 25 and 50 weeks, typically to get switchgear out there. Excuse me. Our simultaneous site construction and manufacturing really meant that we could basically have two crews working at the same time. So as we were building this in our manufacturing facility, we had guys out in the field that were running the conduit, readying the transformer, pads, these kind of things. So we really shortened the construction duration considerably by doing that. And then pre-wired, pre-commissioned. So these were wired up and powered up before they left our facility and actually tested charging vehicles on our facility. So it eliminates a lot of the trying to figure out issues in the field, those kind of things. So that also is another time saver. And this is more of a bloopers reel, or just some of the things. We added security cameras, which that's another thing I'd tell a lot, especially public facing CPOs. Very nice to have is cameras when there are issues. You can look and see, okay, what kind of vehicle it was, and try to nail down, is it a vehicle specific problem or something like that. But the top picture here was they really didn't call us and let us know they're coming, but I'm assuming it was a GM, engineering team that came all at once, a bunch of test vehicles. In this case, I'm not sure what car that was, but it was a prototype car. One unique thing about this car, it actually was a NACS cord on this was not CCS. And then what you see in this van, they were actually testing throughput. So you can kind of see they plug in and actually test the output of the charger and throughput to the car itself or the van itself. So kind of a unique thing that we caught on the camera one day. And this is kind of I guess it's the walk of shame or whatever, as an EV driver. But this gentleman rolled in empty one day. We caught that on camera as well. So not fun to be in that position, but we're just thankful that we're there to, little more charging infrastructure in West Virginia to help folks like that get stranded in some of these hills and mountains here. So that's pretty much it, Greg. I guess I'll open it up, to you to however you see fit to take questions or
I appreciate it. Whatever. We can stay on this slide too if you'd like. Sure. We're gonna have a little bit of a question and answer session with Nathan and I. So feel free to come off mute and ask your question. Raise your hand through the Zoom meeting, of course, not like physically raising your hand, or just pop your question in the chat. Does anyone have any questions?
Okay, I'll go. What's the unit next to the charger that's not the switch gear? Is that an inverter?
So you speaking of like the Parkway projects in particular?
Yeah.
Yeah, so that's basically invert rectifier. So it's converting 480 volt AC to the 1000 volt or 950 volt DC. So these would be what I would call a distributed DC system. They're not all in one. So they're taking the power and distributing it throughout to the dispensers themselves.
What platform are they using to host? Who does the EV drivers see when they pull up?
So we basically have our own, well, in these cases for the Parkway, I have considered using an app, but to be honest with you, just using the tap to pay point of sale seems like it's getting the best results. We basically use the same software that EVgo, Francis Energy. We basically white labeled software for our own, CPO uses as DC America.
No, it's pretty cool because as an EV driver, I have a folder with probably 5 or 6 different apps in it for paying different charging vendors for when we travel.
Yeah, I guess I'll take suggestions, but up until this point, it seems like we've gotten more positive feedback from not having an app and just rolling up and tapping your card or using Google Pay or Apple Pay or whatever. I think
I love that.
Yeah, that's a much more convenient way to pay. We have a question from Steve. Have you done or have plans to do multifamily unit parking lots or garages?
For us, typically that's going to be level 2 charging. I'm not going to say it doesn't make sense, financially, but it's a little harder for us to compete in that market. There's a certain cost to entry with this infrastructure to build it strong enough to handle being able to lift all the equipment plus the structure itself. So it's a little harder when it comes to level 2 charging to make that make sense. We're trying to find more economical ways to do that. And there's ways of doing it. There's companies that's done it in the past, but typically they would wire it in the field. They would put down the infrastructure that's above ground and they would wire these things in the field, which, I guess there's advantages and disadvantages to that. But just being able to pick these up requires a certain amount of structure. I mean, they're I'm not going to say they're heavy, but to be able to pick these up, some of these units could be 6, 8, 10,000 pounds. Yes, I'll give you, for instance, these rectifiers here, they're probably approximately 2,000 pounds a piece. So the structure to hold those up is quite robust. Yeah, I would consider it. We're looking at ways to do it more economically, and I think there's markets for what you mentioned there. dwelling units, those kind of things. But I'm just trying to figure out how to do that a little more economically and make sense ROI wise for those clients.
Is it just a matter of the number of charges put in? Because I know a lot of multi-units, they start with a relatively low number, but there's some large units out there that probably have surface parking where the weight's not the problem, but maybe it's the quantity of charges to, as you say, make it more economical. I didn't know if that was the main issue.
Yeah, the economics part of it is like I would typically be competing against on a level 2 charger, like a single 1-inch PVC conduit rough end with smaller wire. Whereas in DC fast charging, where my platform is a lot more economical, is the fact that you're using typically a lot larger conduits, more wire. So that entry cost with the DC fast charging, typically I'm at parity or less than typical stick built construction costs. Whereas with typical level 2, it's going to be a little more pricey. But if you've got a client that is kind of thinking about the scalability of this and potentially maybe doing fast charging in the future, you're basically putting in a lot larger raceway than what you would typically need for a level 2 system. So with the scalability aspect of this, if you wanted to switch to DC fast charging later on, I'd say the all-in-all cost in the end would be lower by doing it like this, because you're not having to redo all the foundations, all the raceways, wiring, those kind of things to make it work.
Okay, thanks.
Yep.
Another question from Humphreys is, I presume most of your installations are quote unquote permanent or long-term. Do you see much interest in short-term leasing or rental of a station? And are your installations designed for easy removal as well as installation?
Yeah, I think I guess to answer the first question, there's a lot of interest in rental units. In the beginning, I was more seeing like single units, let's like a single charger, all-in-one charger on a platform that could be portable with a pallet or a pallet jack or a fork truck or whatever with quick connections. I've actually got several of those out there to different bus clients or middle mile clients, folks like that, who are renting those off of me currently. That's not really our business models to rent these, but customer calls, they're in trouble, we try to help them out as much as we can. I'm seeing more and more desire or need, I guess, for larger scale stuff like what you see in this picture. Quick deployment, cam lock connections like what I showed you earlier, and then the ability to redeploy it. So to give you an idea on redeployment, just as quickly as you can set it, I can unwire probably one of the ones on the Parkway here in West Virginia in less than an hour. I could have it unbolted into the truck probably less than 2 hours. So it could be on the road to another location very quickly. It's designed with that in mind. But it's definitely a permanent installation, but redeployable is very easy to do.
What is the life cycle of your chargers or lifetime? So I will say one of the nice things about your chargers is that you can, because of the wire raceway, you can kind of like rip and replace pretty easily. But what is your hope or your idea of how long these chargers can last out in the field?
Yeah, the chargers themselves, depends on what hardware manufacturer you talk to out there. I guess some of them will say 5 to 10 years, 10 years. In my experience, what I'm seeing out there currently, I'm going to say 5 years is probably for the chargers themselves. It's probably going to be potentially antiquated in that time frame. Speaking of being able to redeploy these, I think it doesn't necessarily mean it's unusable. I think the application could potentially change. When I say that, let's just say today you have 150 kilowatt chargers that are on the interstate, which, by some people's means, that may be smaller than what they want. The majority of cars, that's all they can handle these days. It's probably the most robust, typically in that range, that you're going to get out there. When you start getting into the higher wattage chargers, you start getting the liquid cooled cables, those kind of things. So when I say you could change applications, that 150 kilowatt charger may not be an interstate charger in 5 years. It may be a great application for, um, a grocery store parking lot, somebody somewhere or a restaurant or something like that that's trying to get the public to engage and sit there longer. A solar charger is fine in that application. Whereas you may want a 350 kilowatt to replace it, or whatever's next out there. I don't think megawatts going to really affect public charging, but 350 kilowatts, you probably see that more and more and more, as those get more reliable. Hopefully I answered your question.
Oh, you definitely did. Thank you so much. Yeah.
I have another one. How'd the utility conversation go when you guys contacted them and you were like, I need a 1500 kVA 3-phase 480 volt transformer in 2 months to be able to run those chargers at the travel plaza?
Yeah, it helps to be local. I'll say that. I mean, existing relationships with the utility company. I think, they wanted to see these projects. AEP wanted to see these projects successful for the parkways. That helped. The parkways knew that they were going to put EV charging in fairly early on. I think, they waited a little while to, determine how they were actually going to do the EV charging. But initially, they always knew that they were going to put this in. So conversations were had with the utility fairly early on about this. They just didn't know exactly what they were going to do with it yet. But having
Okay.
local relationships with folks helps, and there's some strategies you can use there as well too. I mean, I can get transformers fairly quickly, and I'm not saying every utility will allow this, but there's a lot of utilities out there will let you purchase primary power. So I could theoretically own that transformer at these locations, and the power company would just sell me primary or medium voltage power. It's typically a lower demand rate, typically lower consumption rates. All the risk, comes on me with the transformer at that point. But for folks that are looking for fast deployments, there are options out there to get transformers quicker, like that.
Yeah, and if they were having the conversation early, then maybe they already had some transformer ideas they needed them going into it. So, okay.
I think transformer, it's getting a little better, the lead times on transformer. I'm going to say it's great, but
definitely on the residential side too, like the 10s and the 25s, 15s and stuff, it's looking a lot better, but the big ones are still taking some time to get.
Yeah.
Have you seen much deployment of your chargers into like disaster areas or in like a defense contract kind of way?
We're working towards that. There was some talks about that with the floods there in North Carolina. Duke Energy has a lot of Silverado EVs, and it becomes problematic, when you take all your trucks to where they have their infrastructure, and you're moving them to another location where either the infrastructure is decimated or it's not necessarily there. I think a lot of people are still in its infancy. We're talking to some utility companies on the West Coast, about things like this. It's definitely on their map. It's definitely on the radar. Some of these companies have huge plans to electrify their fleets. So it seems like I'm seeing a lot of utility companies wanting to do that. So you're definitely going to see that more and more. And I think mobile charging is very appealing to them, based on conversations I've had.
Cool. Thank you so much.
And just if you don't mind, just a quick comment about that. I mean, I think Tesla for crowded EV supercharger stations, they'll roll in some chargers on a flatbed in terms of portable. I don't know if that's what you were thinking about or something not quite as portable as that.
Yeah, I mean, that's pretty much what we're doing here. I mean, we could, if you look at this, obviously wrapped for shipping, but we could put a generator, energy source, or whatever on a trailer. In a lot of these cases, Steve, what I would say, they would probably set this unit off and then just have a generator on site, so they're not tying up trailers, and power this up, off the grid for these kind of applications. A lot of cases we would look at just doing. I'll tell you what. Let me back up. I'll show you what I'm talking about. Something similar to this. You can see the fork pockets, so that enables us to pick this up. It's designed to basically be set between the rails of a pickup truck, so it's 4 foot wide. So we can pick this up, set it on the ground wherever, set multiples on the ground wherever, and it has the 480 volts or whatever power connection, basically pre-wired to where all it would have to do is plug into a connection like what you see here. So it's just like a heavy duty extension cord.
We have another question from Andrew. Welcome back, Andrew. Do you have any installations which include vehicle to grid?
So, I have, in some cases, we don't necessarily provide the charging equipment for every customer we have out there, but I have built platforms that have V2G chargers on them. I don't necessarily know every location where some of these clients take these, but the intention was to do some testing with it. I'm not going to say it's that's definitely not the majority of what we install, but I have seen some of those, and we have installed some of them on our platforms. Yes.
Cool. You mentioned earlier about using them for school buses, like in heavy duty space, and potentially having ones like loaning them out or leasing them out to some of these schools with these buses. For those buses or for those school districts, are they allowed to share them within the school districts? Because obviously there's more than one school usually in these areas. I'm thinking like maybe there's like a module charging share, so like buses change routes sometimes. Is that allowed for them to do that, or is that something you guys even thought of?
I'm not sure 100% I got your question there, but in the particular instance that we've done it in the school bus, like I have a bus dealer that's in the Southeast. They keep 2 of our units just for customer service on their end, and they'll deploy them at whatever county's having an issue. Great service on their part. They're great people to do that, and they're assuming the cost of this for their consumer base out there. But they may move it to one county until they can get the chargers up at that facility, pick it up, take it to another one, or take it back to their home location. But they keep it just for that.
Yeah, that kind of answers my question. I was more thinking of like, so like maybe a school board or school district doesn't have enough money to buy like 10 DC fast chargers, right? But they could afford to buy one modular unit from you and share it within the school district. And I was just curious if that was something that you have seen or if that was something you would do. Does that make sense?
I guess I'm kind of hard-headed, Greg, so I may not be getting you 100% here, but
sorry.
But we definitely have sold like a single charge. I guess in most of the districts I'm dealing with, they probably have a single transportation depot,
right.
and they would probably bring all the buses back there. I think maybe what you might be talking about is just say there's another county next to it that potentially may share the assets. Is that what you're saying, pretty much?
Yeah. It's so I do a good bit of work in like rural areas, and so like a lot of the bus drivers in rural locations like take the buses home. They don't come back to a central location. And yeah, so to answering my own question is like, sounds like that's not something that you do, but what you are doing with your or that you've encountered yet. But what that bus dealer is doing is very similar. They have 2 of these modular units that they can assist their customers with.
I gotcha.
You know, deploy them out. So like that's very cool in itself. And we'd love to actually know more about that. And maybe we could do like a little blog post about it.
Yeah. There is one dealer that I'm dealing with that, it gets fairly expensive to move electric school buses around, on trailers.
Right.
It's a lot cheaper to drive them to their final destination, but electric school buses are somewhat limited in range. They really don't need 300, 400 miles. So and you may be aware of this project as well, but there's a project that we're helping a dealer with that they basically are building a depot strategically in a location to where they can take the buses from the manufacturer, which is a little further south on the East Coast, and then move them up to a pretty populous area. So basically almost like a relay station. But it potentially could be used for something like this as well, and I think they have intentions of opening up this depot to others. That's the key, in my opinion. If you want to make money with EV charging infrastructure, you have to drive utilization. It has to be utilized a lot for it to make sense. If you're only using it once or twice a day, the cost for investment is just ridiculously high. So, I'm seeing this with rideshare folks, people like that are basically building depots that are multiple people are using this. It might be a school bus, county school bus system. It might be rideshare folks. It might be, uh, uh, airport buses or whatever. But multiple people will use the same location, which really helps with utilization, which really makes this a lot more, financially reachable, achievable to make some money at this and make it make sense for folks. It's expensive. I mean, if you have 4 buses and you want to put 4 chargers in, 4 DC fast chargers, I mean, it's somewhat cost prohibitive for a lot of these schools. So, like what you're talking about here, maybe some strategic planning and locating, this kind of infrastructure really makes sense to get more utilization out of it.
Yeah. We have one last question because we're getting close to the hour here. Andrew, again, do you run into many sites which have, say, 3-phase 208, but not 3-phase 480? What's the average cost and time to upgrade power?
Yeah, so I mean, you see that, especially in rural areas. I think there's an application, for products. Light On makes a basically you can take single phase and have a DC fast charger, which typically be powered by 480 volt. A lot of the EPA Clean Bus Program grants that I've seen out there, a lot of these counties are getting 1 or 2 buses. So it is somewhat cost prohibitive for them to put a whole new electrical service in just for 1 or 2 buses. So applications for chargers, which they exist, that take single phase power and create, 40, 60 kilowatts of DC fast charging power, they're out there. And they make a lot of sense for smaller applications like that for a district that's only going to get 1 or 2 buses. And there's tons of them out there that are in that boat. They really don't want to spend that money to put a whole new service in. So definitely application for that.
Cool. Well, I'm gonna call it a little 5 minutes early. Thank you guys so much for asking all the questions and being attentive, and a special thank you to Nathan for presenting today. Like I said before, this will be recorded and posted to the Virginia Clean Cities YouTube account, and we'll also email you a link to the video once it's posted as well. So thank you guys so much for having spending your Thursday afternoon with us. We will see you all soon.
Thanks, everybody.